When you think of black holes, you probably picture something from a sci-fi movie, right? These cosmic monsters just gobbling up stars and planets. And yeah, they are without a doubt the most extreme, most mysterious, and most powerful things in the entire universe. But how do they actually work? So, what if I told you that to really get your head around this cosmic giant, you don't actually need a PhD in astrophysics? Nope, you just need to understand something you've probably seen 1,000 times. Yeah, a bathtub drain. I'm serious. That little swirling vortex of water, it holds the fundamental secret to how a black hole operates. Okay, so let's dive in and see how on Earth, a simple drain can explain a hole in space-time itself. All right, to really wrap our minds around this, we're going to use an idea that physicists call the river model. So try to forget everything you think you know about black holes being giant vacuum cleaners. Instead, I want you to picture space itself as a river, and it's all flowing towards this massive cosmic waterfall. And this is where the whole analogy just clicks. See, just like water flowing towards that drain, space-time itself is constantly flowing into the center of a black hole. And the closer you get, the faster that current of space flows. And eventually, you hit a point where the river of space-time is flowing inward faster than the fastest thing in the universe, light, can possibly swim upstream. And that's the whole key. A black hole isn't really a thing you can point at. It's more like a place. It's a place where space-time itself has just gone right over the waterfall. Okay, so let's get the official definition down. A black hole is basically what you get when you cram an absolutely unbelievable amount of mass into an impossibly tiny space. And all that mass creates gravity so intense, it warps space into that inescapable cosmic river we were just talking about. But how in the world do you even make something like that? Well, it all starts with the death of a truly massive star, and a process you could honestly call gravity's final absolute victory over every other force in the universe. It all goes down in a few pretty catastrophic steps. For millions of years, you've got this massive star that's in a constant tug of war. Nuclear fusion is pushing everything out while gravity is trying to pull it all in. But then, the star runs out of fuel. That outward push just stops, and gravity wins. Big time. It crushes the star's core with this unimaginable force, squeezing it down and down and down until it completely collapses into a single point of infinite density. And just like that, a black hole is born. To give you a sense of just how insane that density is, think about this. If you could somehow take our entire planet, I mean everything, all of it, and crush it down until it became a black hole, it would be just 9 millimeters across, about the size of a marble. The mountains, the oceans, all of us, packed into something smaller than your pinky nail. It's wild. So now we have this incredibly dense object, and it's just sitting there, warping space-time all around it. So let's take a look at its anatomy, because this is where things get really, really weird. First up, we've got the most famous part, right? The event horizon. Now, this is not some physical surface you could go up and touch. You got to think back to our river. The event horizon is just that line in the water where the current gets faster than the speed of light. Once you cross it, it doesn't matter which way you try to swim, the current of space itself is pulling you in. There is literally no direction that leads out anymore. And where is that current taking you? Well, it's heading to the singularity. This is the very center, the point where all that matter from the star is crushed into a single point. You know when you tried to divide by zero on a calculator and it just gives you an error? That's kind of what the singularity is for physics. It's a place of infinite density and infinite gravity where our rules just break down. We can't get an answer. So what would happen if you were, unlucky enough to fall towards that singularity? You'd experience something that scientists, and this is a real term, called spaghettification. The gravitational pull on your feet would be so much stronger than on your head that your body would literally be stretched out like a piece of spaghetti. It sounds bizarre, but it's a very real consequence of that kind of extreme gravity. Okay, so spaghettification is totally real. But a lot of what we think we know about black holes, yeah, that comes straight from sci-fi movies. So let's clear up a couple of the biggest myths out there. All right, myth number 1, the big one. Black holes are cosmic vacuum cleaners. They're just not. They don't roam around the universe, sucking things up. From a safe distance, their gravity is no different than a star of the same mass. In fact, if our sun were to magically get replaced by a black hole with the exact same mass, we'd all get very, very cold, but the Earth would just keep on orbiting like nothing happened. And myth number 2, they are not portals. As far as we know, they don't lead to another dimension or a different galaxy. They are a one-way trip to a dead end, plain and simple. Okay, so Nothing can escape, not even light. They're the ultimate cosmic dead end. That's why we call them black holes, right? Well, this is where the story takes its most absolutely mind-bending turn yet. I mean, are they just destined to keep growing and growing forever, just swallowing up more and more of the universe until the end of time? The answer, incredibly, is no. And that's thanks to the absolute genius of Stephen Hawking. We have this theory called Hawking radiation. And what it does is it combines the total weirdness of quantum mechanics with the intense gravity of black holes, and it predicts that black holes aren't completely black. They actually glow, even if it's just ever so faintly. So how is that even possible? Well, in the super strange world of quantum physics, empty space isn't actually empty. What's happening is that tiny pairs of particles are constantly popping into existence and then immediately disappearing. But right at the very edge of a black hole's event horizon, a pair can get split apart. Look here, one particle falls in, but the other one actually escapes. That escaping particle is Hawking radiation, and to pay the universe's energy bill for making this particle, the black hole has to give up a tiny, tiny piece of its own mass. Now, this whole process is unbelievably slow. I mean, a black hole the mass of our sun would take way, way longer than the current age of the universe to evaporate. But if you give it enough time, and we're talking trillions upon trillions of years, this steady little leak of Hawking radiation will cause the black hole to shrink until it finally evaporates away in one last flash of light. So black holes aren't eternal prisons after all. They're born from the collapse of giant stars, they warp space-time like a river going over a waterfall, and eventually they just fade away over eons. They really do represent the edge of our knowledge, right? The point where our two greatest theories, gravity and quantum mechanics, just don't get along. And it really makes you wonder, what other secrets are waiting for us out there, hidden just beyond that point of no return?